All right, here's your Chapter 5 Analytical Trig quiz review. All right, so number one, it says simplify the following trig expressions. So here we have sine squared x minus sine squared x cosine squared x. All right, so the first thing you want to do is, since both of these terms have a sine squared x in them, you're going to want to pull out the sine squared x. So when you pull out a sine squared x from sine squared x, you're left with 1 minus, when you pull the sine squared x out of here, you're left with cosine squared x. Alright, by now you should recognize this as a golden rule. This right here equals sine squared x. So our final answer is sine squared x times sine squared x, which is sine to the fourth x. Alright, so there's number one. Number two, prove the following trig identity. Now remember, when you're proving these trig identities, you want to end up with one of three things as your answer. Number one, you want to end up with the same thing on both sides. Number two, you want to end up with 1 equals 1. Or number three, you want to end up with one of the three golden rules. All right. So first thing I would do here, since we see these two sets of parentheses, and since they're identical except for plus and minus, this will be the difference of two squares when you multiply them together. So we know that this is going to be sine squared x minus cosine squared x. That's one of the special cases when you're multiplying binomials. Okay, this is one of those special cases. Now, the next thing you want to do, we have cosine squareds and sine squareds, and we have a 1, so the chances of this coming down to a golden rule are great. So the first thing I'm going to do is subtract 2 sine squared x from both sides to get all of my sine squareds and cosine squareds on the same side of the equal sign. So sine squared minus 2 sine squared is, let's move down here guys, is negative sine squared x minus cosine squared x equals negative 1. Now all my terms are negative, and I know that the golden rule that deals with sine squared and cosine squared, everything's positive. So if I just multiply everything here by negative 1, I get sine squared x plus cosine squared x equals 1. So there's our golden rule. So there's number 2 completed. All right, number 1 again came out to sine to the fourth x. Number 2 came out to the golden rule. Sine squared x plus cosine squared x equals 1. All right, let's clear my ink and keep going. All right, number 3, solve for theta. And we have 8 times the sine of theta equals the square root of 3 plus 6 sine of theta. First thing I would do is get all the sines on one side. So subtract 6 sine. I was saying theta, it's alpha. Doesn't really matter. All right, so now we have 2 sine of alpha equals the square root of 3. Divide off the 2's. So now we have the sine of alpha equals the square root of 3 over 2. All right, I gave you this chart. So now what you need to do is go back up to this chart and figure out where the sine, I'm sorry, it's kind of over the chart now. Oh, move it. Where the sine of alpha equals the square root of 3 over 2. Well, here's sine square root of 3 over 2. That's pi over 3. So now, remember, you always go to your reference angle in the first quadrant. All right, we know this is going to be pi over 3. We're dealing with sine, so we know we're going to be in quadrant 1 and 2 because our sine is positive. So now we're also going to have an angle of pi over 3 right here. All right, so now we need to figure out what these two angles are. Well, since we're in the first quadrant, it's just our reference angle. So our first angle is pi over 3. Our second one here, it's pi over 3 less than halfway around. So that's pi over 3 less than pi. Well, when you're subtracting a fraction from a whole number, you got to get the whole number over the same denominator. All right, so this is pi over 1, so we're going to have to multiply the top and the bottom by 3 to get 3 pi over 3. Okay, 3 pi over 3 minus pi over 3 is 2 pi over 3. All right, so our two answers for number 3 are pi over 3 and 2 pi over 3. All right, remember, it all goes back to reference angles. Regardless if this was negative, I would have still done my reference angle in the first quadrant. And then if it had been negative, I would have been working with the T and C quadrants instead. So I would have added here and got 4 pi over 3, and then subtracted on this side, subtracted from pi over 3 from 6 pi over 3 and gotten 5 pi over 3. All right, so let's keep rolling. Solve for x. So here we have 2 times the sine of 3x minus the square root of 2. All right, so after you solve for the sine of 3x, you're going to get that the sine of 3x is the square root of 2 over 2. You should be able to get that far now. All right, so temporarily ignore this 3 for now. Okay, so we'll go to our first quadrant. We have pi over 4 as our reference angle. We're dealing with sine, so that's A and S. So that's the first 2 quadrants. So here again we have a reference angle of pi over 4. All right, so now we need to figure out what this angle is. Again, you're going to subtract it from 4 pi over 4 because again 4 divided by 4 is 1. So this is still 1 pi. So, and of course our other angle is in the first quadrant. So our first 2 answers are pi over 4 and 3 pi over 4. All right, because this one is pi over 4 less than 4 pi over 4, so it's 3 pi over 4. Now, this 3 means we go around the circle 3 different times. All right, when we go around the first time, these are our 2 answers. All right, to get the 2 angles when we go around the second time, what we have to do is we have to add 2 pi to each of these answers. Well, again, since we're adding fractions and whole numbers, 2 pi is going to have to come out to 8 pi over 4. All right, all I did was multiply the top and bottom by 4 to get my 8 pi over 4. Now I'm going to take this because 8 pi over 4 is 1 full circle. All right, so now I'm going to add that to both of these angles that we just got. So 8 pi over 4 and pi over 4 is 9 pi over 4. 8 pi over 4 plus 3 pi over 4 is 11 pi over 4. Okay, now we're gonna have to get 2 more angles because so far we've only went around the circle twice, but since it's the sine of 3x, whoops, said 3 and wrote 3, but since it's the sine of 3x, we have to go around the circle 1 more time. All right, but now instead of adding to these angles, because if we add 2 pi to these, we're just going to get these again. Now we're going to add the 8 pi over 4 to the 2 new angles we just got. So 9 and 8 is 17 pi over 4, and 11 and 8 is 19 pi over 4. All right. Now we're still not completely done. We have to take all of these angles and multiply them by 1 over this number. All right, multiply them by 1 over 3. So now, our final answers for x, because these aren't our final answers, our final answers for x are all of these angles multiplied by 1/3. So the only thing that's going to change is all of these 4's in the denominator are going to become 12 because 4 times 3 is 12. So our final answers are pi over 12, 3 pi over 12, 9 pi over 12, 11 pi over 12, 17 pi over 12, and the last one is 19 pi over 12. So those are our 6 angles that will satisfy this equation. All right. Now, if you look at the answer key, this one here is listed as pi over 4. That's just because they reduced it. And this one here is listed as, I believe, 3 pi over 4. Again, that's just because they reduced them. You don't have to reduce them. If you want to, you can. But just keep in mind, if you reduce them and you reduce them wrong, I'm counting the answer wrong. All right, because I will take them in unreduced form. All right, so these are your final answers, unreduced, and you can reduce the ones that can reduce if you want to, but you don't have to. All right, moving on. Last 2 problems. Now, this Santa Claus stays cool in summer and cross-country runners skip school, I didn't really teach you all that. I left it on here, but I didn't teach you all that. But here's what it means, basically. when you have your sine of alpha plus beta, the Santa Claus, you remember here how it's the sine of the first times the cosine of the second, and then of course this is plus or minus, so this is plus or minus the cosine of the first plus the sine of the second. Well, it's just Santa Claus is sine cosine stays, the sign between them stays the same. Cool cosine in summer, so it's just sine cosine same cosine sine, and this is the one for the cosine. If it confuses you, just ignore it, pretend it's not even there, and then just fast forward through this little explanation of what that means. So now cross-country runners, it's the cosine of the first times the cosine of the second. Now the runners means reverse because you reverse the sign between them. So if you add, it's going to be subtract. If you subtract, you're going to add. And then just the sine of the first times the sine of the second. All right. So like I said, the Santa Claus stays cool in summer, and the cosine and the cross-country runners, it's just a it's just something to help you remember these. Okay, it's just something to help you remember these. If you remember these, don't worry about this. All right, I never learned it this way. This is just something I found. So if it helps you, use it. If it doesn't help you, don't worry about it. All right, so let's get going. We want to find the exact value, no decimals, for the sine of 15. Okay. So what we need to do is we need to find two values that are on our chart at the top of this page. I'm not going to go back up to it right now. But the sign at the chart at the top of this page, two values that either add or subtract to give you 45. All right? I mean 15, I'm sorry. Well, the two values that will is 45 minus 30. All right? So we're going to have the sine of 45 degrees times the cosine of 30 minus the cosine of 45 degrees times the sine of 30. All right. So the sine of 45 is square root of 2 over 2. The cosine of 30, if you go back up to that chart, cosine 30 is square root of 3 over 2. Okay, square root of 3 over 2. Minus the cosine of 45, which is square root of 2 over 2, minus the sine of 30, which is 1/2. Now, you just multiply these together. Square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Minus square root of 2 over 4. Write them as a single fraction. Square root of 6 minus the square root of 2 over 4. Remember, leave these radicals separate. Don't try to subtract them. It is not the square root of 4 over 4. All right, it's the square root of 6 minus the square root of 2 over 4. All right. Now, let me get rid of this so we can do cosine. Cosine of 75. All right, so the cosine of 75, let's use the same two. 45 plus 30, because again, 45 plus 30 is 75. All right, so we're going to have the cosine of the first times the cosine of the second. Reverse the sign. Since we're adding here, we need to subtract here. The sine of the first times the sine of the second. All right. Cosine of 45, again, is the square root of square root of 2 over 2. The cosine of 30 is the square root of 3 over 2, minus the sine of 45, which is the square root of 2 over 2, times the sine of 30, which is 1/2. All right, now you just multiply them together. Square root of 2 times the square root of 3 is the square root of 6, over 2 times 2 is 4, minus square root of 2 over 4. Write them as a single fraction. Square root of 6 minus the square root of 2 divided by 4. And again, you just want to leave this alone. You don't want to try to subtract them. All right? So this has been your analytical trig review video. Make sure you understand how to do these 6 questions when you come to class tomorrow. All right? Good luck.